What's up, everyone? Today we are going to practice and learn how to summarize graphs and turn those into words. So we're going to take a graph or a picture of data and learn how to summarize that into words. And that is called the rate and trend of a graph. So if you have a graph and the data goes like that, or the line increases, I don't want you to say the line goes up. That's not a clear understanding of what happens. So we're going to practice today. I'm drawing what are called best fit lines. A best fit line is the line that goes to the data points, and then you're going to practice summarizing those. So that's the plan, people. Let's see how we do. Still getting used to this program here, so it could be a little cumbersome. So you're going to open your journal. You're going to get a ruler, open your journal to the page that has the rates and trends. And there are probably 2 pages, and they look like this. The year I'm recording this video, it's probably page 19 in your journal, but it could be a different page, so double check which one it is. And you probably have 4 of them on there, but I've made them a little bigger on my screen to go through. So the first one, you have some data points that look like this. Now, the first thing you'll notice is that they're not on a perfect straight line, and this happens a lot in science. And the reason this happens is because there are errors that we make when we collect data often. So in science, there are errors or mistakes in collecting data. So imagine using like your stopwatch and you start and stop a race or something, and you might start it a little late or stop it a little late or something to that effect. So there can often be errors in the data, and that's why in math class your data is also often a perfectly straight line. It would be perfect, like all the data points would be on a line, but in science it sometimes isn't. So what we do is we draw what's called a line of best fit or a best fit line. And if it generally looks straight, what we want to do is draw a straight line through the data. So this is a really good to use a clear ruler on, because what you're trying to do is get some of the data points a little above the line and some of the data points a little below the line that you draw, but it's going to be a perfect line. You're not going to draw a line like this. So I'm going to draw a bad line first. You're not drawing a line that goes through the data points like this. Okay. What you are doing is what's called a line of best fit. So let me erase that and show you what a better line would look like. It would be awesome if you could see a ruler on my screen, but that's not going to be the case. So imagine I'm using a ruler, and I'm going to try to line these up so I have some of the data a little below and some of the data a little above. So this would not be a good best fit line. This would not be a good best fit line, but something like that would be a good line. So do you notice how this data point is a little below and that's a little above, and that one's a little below and that's a little above? So you're trying to get you're taking an average of your errors is technically what you're doing. So let's try this one over here. So go ahead and draw your line. I'll pause for a minute. And let's draw the second line. So let's go over here and draw the one over here. So this would not be good because all your data is below. So that would not be a good line. Let me erase that. Maybe I don't know how to erase it. All right, well, we'll leave the line on there and just draw a better line. So ignore that line. So I'm going to use blue for a better line. So I'm going to put my ruler on and go something like that. And it's okay to extend the line a little above and a little below the data point. So it would have been nice if I'd have drawn my blue line a little higher. So red line there is not good, but the blue line is. Okay, now you got to summarize that. We're going to put it in words. So what you do is you always start out with stating the independent variable first, the one on the x-axis here, and you say as this variable goes up, what happens to this variable? So as time increases, as time goes up, distance also goes up. That's why the line is going up. So distance increases. So I'm going to write increases here. At a blank rate. So anytime you have a straight line, it's not curved, we call that a constant or a steady rate. So I'm going to write steady right there. So as time increases, distance increases at a steady rate. So let's try the other one over here. As time increases, distance, does it increase, decrease, or stay the same? Since the line's going down, we're going to say decreases. Sorry, I'm writing with my finger on the screen. It's not perfect. Decreases at a, it's a straight line again, or at least my best fit line is a straight line, so I'm going to call that a steady rate. Boom. Okay. All right. I'm going to go ahead and clear the screen. And try the next ones. So these are the bottom two. Now, if you look at those, it doesn't really look like a straight line anymore, right? So if I drew a straight line through here, it doesn't make sense because you have, for example, you know, these are down here and these data points are above. So it doesn't look as random now. So I would not draw a straight line through those. Rather, I wonder why it won't let me erase. Ah, it did. I would rather draw a curved line through those. Okay, so well, maybe it only lets you erase the last thing you did. So in this case, I'm going to draw a curved line through them, and the key is smooth. So you want to use your pencil. And by the way, you should use pencil on all these. You want to do smooth line, something like that. And you notice I extended it out further than the data points. I'm showing what I think the data would do if I kept collecting data. And on the next one, it's going to be, again, a smooth line. I'm going to try to average the errors that I have in my data. And sometimes I might want to do this more than once, so it's good to write lightly in case I make a mistake. And it's not too bad, actually. So I'm kind of going through, and if you can draw smoother than I can with my hand, that's even better. So I'm just kind of splitting the difference between these two, right, and those two, so it's nice and smooth, okay? Rates and trends. So what I like to do is say, as time increases, distance, is it increasing or decreasing? It's increasing. But what's the rate? It's not steady, so it's either slowing or faster. And what I like to do is imagine there's a line, a slope line that's like similar there, and a slope line to what the line is doing near the top. And you'll notice, like, if you put a marble on here, it would fall down really quickly. If you put a marble here, it wouldn't fall very quickly. It's less slope. So that means the line is going up really fast here, and it's over here, the line is going up real slow. Okay, it's gradual. So if I go from fast at the start of my line to slow, we call that a slowing rate. All right, let's use the same logic here. So on the right side. So first of all, as time increases, distance, is it increasing or decreasing? Good. It's decreasing. So I'm going to write decreases here. At a blank rate. Okay, so again, let's do the marble analogy. So imagine you put a marble on a track that's right here, and you put your marble on that track. It's going to go downhill really fast if you started it right there. Do the same thing over here. Imagine you put a marble on this part of the track and you start it right here. It's going to go downhill, but it's not going to speed up real quick. So here it's going downhill super fast if you just started it on that section of the track. And if you started the other marble on the lower section of the track, it would go downhill slow. Okay. So again, we're going from a fast drop to a slow drop. We would call that a slowing rate. So whenever the line is leveling out at the end, that's a slowing rate. And you'll notice in both of my examples, as you move to the right on the graph, it's slowing down, slowing rate. Okay. Okay. Take a look at your next page. It should have 4 of them, or 3 more. It should be on, might be on page 20 if it's what I think it is. And you have these 3. Okay. I'd like you to try those on your own first. So you're going to pause the video and look at your options here and see if you can figure out which one is which. So pause the video and write lightly, and then I'll double check your answer with you. Okay, well, let's see how you did. So in this case, my best fit line is going to be a smooth line. By the way, you don't always have to go through the XY intercept. You could, if the data is showing somewhere else, you don't have to hit that spot necessarily where your graph comes together. But all the ones I've given kind of show that. So my best fit line is going to look something like this. I'm not loving that. Try it again. Probably a little bit high. I'm still a little bit high. That's why it's nice to use pencil on these in case you want to redo them. I like that a lot better. Boom. Okay, splitting the difference between them. Okay, as time increases, distance, so as time goes up, distance is going up, so it increases. That says increases, people, sorry. At a, okay, marble trick. Imagine you put a marble right here on this part of the line. It's really steep, so it's going to go downhill really fast. And imagine you repeated that, but you started the marble right here. It's going to go downhill real slow. Okay, so you always read left to right on your graph. So left to right means we would start it slow and it would be getting fast, so that would be at a faster rate. And let's do this one. Not bad. Try it again. Like that a little better. So you're not avoiding the data points. I hit those 2, that's fine. If anything, I drew it a little bit low because I didn't do a great job of splitting the difference between those 2. But it's not horrible, so I'm going to leave it like that. So let's do our analysis again. So if we put a marble on the ramp and we let it go from like roll down from here, it wouldn't roll down super quick there. It would roll down slow. And if I put a marble on the ramp right here and let it roll down, it would go really fast. So I'm going from slow to fast. Okay, so as time increases, distance decreases. At a slow to fast is a faster rate. All right. All right, last graph. So in this case, sometimes you have data that just goes across. And again, you're going to do a best fit line that represent that. Something like that. That might be a little low. So try one more time. Boom, that looks pretty good like that. So I'm averaging the data points. And really, if you have a straight line going across, it really means that this variable, the time, has nothing to do with the distance. In other words, you're staying still in this graph. You're not moving. So you would say as time increases, distance stays the same. Okay, as, and I'm just going to use a T for time, and an arrow up for increases. As time increases, the distance, D for distance, stays the same. Go ahead and write that in. Okay. All right. Nice work. All right. Why don't we connect all the dots if it is not naturally a smooth line? So in other words, why do we draw a best fit line? If we have data that is, these are my data points, that is not perfect, why are we drawing a line that kind of averages those? And the answer to that is we are averaging our errors. So we're kind of showing what we think, that blue line represents what we think the data should look like if we didn't make errors collecting the data. All right, draw a graph that shows this. As the power increases, the speed increases at a slowing rate. Go ahead and draw it, pause the video, and we'll see how you did. All right, so power is going to be the variable we changed on purpose. And speed is the variable we're measuring. And we want to show that it increases at a slowing rate. So it's going to be a line that goes up, but it's going to go up at a slowing rate. If you drew that line, you did a great job, because here it would be going up slow, here it would be going up fast. So fast to slow is slowing. All right, that's best fit lines tutorial. Yeah, I had slides for it too. Thanks, you guys.